Today we're going to talk about different ways to analyze a function. So on this first function here, we're going to pretend there's arrows there. And our domain is going to go from negative infinity to infinity, and as well as our range. Now we're going to talk about end behavior. So end behavior here, the limit as x goes to infinity. Now this is the right side of our graph. And so we're going to look over here at the right arrow of our graph. And so that arrow, as we go to the right, is also going up forever, so it's going to infinity. Now we're going to look over here as the limit of f of x as x goes to negative infinity. Well, this is the left side of our graph, and so we're going to look at our left arrow. And we're going to make a note that as it goes left forever, it's also going down forever, so it's going to negative infinity. Now, increasing here, you want to always read your increasing. So we want to read this. I'm going to zoom in a little so we can read my writing a little bit better. But it's increasing. You always want to read this left to right. You're going to use interval notation. And you're going to always use x values. You will also always use parentheses. So if we look at this here, increasing you want to think about is when you have a positive slope. And so our slope here is always positive, and our domain is negative infinity to infinity. So it's going to be increasing from negative infinity to infinity and never decreasing. And so then our x-intercepts are going to be when y equals 0. And here, y equals 0 when x is negative 4. So write that as a coordinate pair, negative 4, 0. Our y-intercept is going to be when x equals 0. And so that's going to be at the point 0, 1. And then to figure out if this is a one-to-one function, it has to pass the vertical line test so that you know that it is a function to start with, but it also has to pass the horizontal line test. And the horizontal line test works the same as the vertical line test. So we're going to draw a bunch of vertical lines, and we see that it passes the vertical line test. But then we also want to draw a bunch of horizontal lines, and we see that it passes the horizontal line test. So therefore, we can determine that, yes, this is a one-to-one function. Now we have a parabola. And the domain of this parabola here, which is a quadratic, is negative infinity to infinity. The range goes from negative 1 to infinity. The end behavior, now remember the end behavior of limit of f of x as x goes to infinity is the right side. So we're looking right here at the right arrow. And as this is going right forever, it's going up forever, so it's going to infinity. And then the limit of f of x as x approaches a negative infinity is the left arrow here. And as we go left forever, we go up forever, so this is also infinity. Now, increasing, again, remember, is when we have a positive slope. So the slope of this parabola is positive right here. And so that's going from x value of 2 all the way out to infinity. So we're going to say it's from 2 to infinity. And then this is decreasing or has a negative slope over here. And so that's going from the x value of negative infinity out here all the way over to 2. And so now, is this a one-to-one function? Well, if you look, this actually will not pass the horizontal line test, and so that tells us that no, this is not a one-to-one function. So now we have a relative and absolute minimum. That is when a minimum here is when you're going to create a valley. So if you were to pour water into this, would it hold any water? And the answer is yes. So we have a minimum. And that minimum is right here at the vertex, which is at the ordered pair of x is 2, y is negative 1. We have another parabola here with a domain of negative infinity to infinity and a range from negative infinity to 2. Our end behavior, so the limit as x goes to infinity is going to be the right side here. So as we go right, we go down, and so we're going to negative infinity. And then the limit as x goes to negative infinity is the left side here, and as we go left, we go down, so that's also negative infinity. Now we're increasing when we have a positive slope, and so our slope is positive right here. And so we can say that that's going from negative infinity here over the x value of 3. And then we're decreasing right here, and so we can say that as from 3 over to infinity, we are decreasing. Now this would not pass the horizontal line test, so it's not 1-to-1, and we have an absolute maximum at the vertex here, and now a maximum is going to create a hilltop or mountaintop, however you want to think about it, and that's going to be at the ordered pair of 3, 2. Now we have this absolute value function here, where our domain is negative infinity to infinity, and our range is going from negative 4 to infinity. The end behavior is the limit of f of x as x goes to infinity is the right side, and as we go right forever, we also go up forever, so that's infinity. And the limit of f of x as x goes to negative infinity is the left side, and as we go left forever, we go up forever, so it's also infinity. It's increasing when our slope is positive, and so that's going from the x value of negative 1 over to infinity. And so that's going to be the interval 1 to infinity, and it's decreasing from negative infinity over here to that x value of 1. So we're going from negative infinity to 1. The x-intercepts, again, are when y equals 0, and so this is going to cross the x-axis at negative 3, so we're going to end up with 2 here, so I'm going to zoom in so I can write a little better. But we're crossing at negative 3 right here, so we can write the point, negative 3, 0. And then if we were to continue this over here, we can see that if we went up 1 over 1, we'd cross at positive 5. And so we also are going to be at the point 5, 0. Our y-intercepts are right here at negative 3, and so that's going to be when x is 0, so that's at 0, negative 3. Now this is not 1-to-1 because it will not pass the horizontal line test, and there is an absolute minimum at the vertex of 1, negative 4. So now here we have an square root graph, and so the square root graph, our domain is going from negative 4 to infinity, and our range is going from 1 to infinity. This is always increasing because the slope of this is always positive. So remember, it's talking about our domain here, though. So it's increasing from negative 4 to infinity, and it's never decreasing. The x-intercepts are when it would cross the x-axis or when y is 0, which never happens, so there are none. And the y-intercept would be here at 3, so it's going to be at 0, 3. And this here, if we look, would pass the vertical line test as well as that horizontal line test. So we can say that yes, it is 1-to-1. Now we have a cubic function here, where our domain is negative infinity to infinity, and our range is also negative infinity to infinity. As the limit of f of x as x goes to infinity is the right arrow here, and as we go right forever, we go down forever, so that's going to negative infinity. And the limit of f of x as x goes to negative infinity is our left arrow here, and as we go left forever, we go up forever, so that's going to infinity. Now this is increasing when our slope is positive, and you'll notice our slope is never positive, so it's never increasing. And it's decreasing when our slope is negative, and the slope of this is always negative, and so therefore we can say that it's decreasing from negative infinity to infinity. And the x-intercepts would be right here at 3 where it crosses the x-axis, and so that's going to be at 3, 0.